can't believe what I just did. I made this video of the lesson that I'm going to do right now, and then I dragged it into the trash instead of dragging it to YouTube. So, okay, here we go again. This video, in this video, we're going to talk about finding critical points, and specifically in section 4.1, we talk about not only finding critical points, but locating maxes and mins and where f is increasing and decreasing. But the most important thing before you can figure out any of the behavior of f of x is to be able to locate where the critical points are on the curve. As you may have remembered from the last video, if a curve has high points and low points, and you've got endpoints, and then you've got those points in the middle where you have the high spots and the low spots, well, that's where either f prime is equal to 0 or f prime does not exist, and those are what we consider and define to be critical points for the graph of f. Okay, so f has critical points, and that's what we're going to be finding right now. So let's go ahead and do that. F prime is equal to 0. That's our first spot. Now, what I'd like to make mention of, though, first of all, here is this f of x that we see here is a polynomial function. We know that polynomial functions behave consistently. In other words, they don't have any breaks in the graph. The domains of all polynomial functions are all real numbers, and the graphs of polynomial functions are nice and smooth. So never will we ever have a critical point on a polynomial function where where f prime does not exist. Okay, so f prime does not exist. That's not going to happen on any polynomial functions. So let's keep that in mind. If I overlook saying, hey, by the way, we need to find where f prime doesn't exist, well, I tend to not talk about that when I'm talking about polynomials. Okay, but in my next example, we'll bring one into. We will do one a function and look at a function that does have a spot along the way where f prime does not exist. But anyway, I just want to make mention of that. F prime equals 0 when, well, first of all, we have to find f prime. So let's just kind of erase that right now. F prime equals, that's what I want. F prime equals, just using the power rule here, we see the derivative of 8x cubed is 24x squared, and then plus 162x minus 42, and that's our f prime. Okay. Well, we want to know when f prime is equal to 0 when, okay, well, when this function f prime, it is a function, keep that in mind, is equal to 0. Well, we don't want to factor it in its current form because we have some common factors. I can see that 6 goes into 24 and 42, and then 6 goes into 162. 2 times there, we've got 12, 42. Okay, so yeah, 6 does go into 162. So I can see we have a factor of 6. The first time I did the video, I divided by 2 and then divided by 3. So if that's something you want to do, go ahead. I'm going to divide by 2, and it'll be easier to see what 6 has to be multiplied by. But then I'm going to notice here that I have a common factor of 3 among all 3 terms, and so I'm going to divide every term by 3, and I'm going to get 4x squared plus 27x minus 7 is equal to 0. Okay, so I could have divided every term in the original equation up here, right here, by 6, and anyway, we're going to go ahead and factor this. Even in AP Calc, I noticed that some students really struggle with factoring polynomials that the leading term is something other than 1. The coefficient, I should say, leading coefficient. But anyway, I already kind of know where we're going here, so I'm going to choose 4x and x. I originally would have chosen 2x and 2x, but I already know that doesn't work. 2x and 2x, you're not going to get all the way to 27, so that we're going to erase that. So that's another possibility for the first 2 factors. But then I need to get to 27 close to that, so I'm going to put my 7, let me back that up, put my 7 right here and my 1 right there. 4 times 7 is 28. That leading, that term has to be a positive. So positive 28 and a negative 1 gives us positive 27. So however you do your factoring, you need to be able to factor polynomials like this, but nevertheless, f prime is equal to 0 when 4x minus 1 is equal to 0, or when x plus 7 is equal to 0. So our critical points are going to occur here where x is equal to 1 over 4. And I just want to double check. I added 1 divided by 4. Okay, got that. And then I'm going to subtract 7 from both sides here, and I get where x is equal to negative 7. So I get my two x values in which f of x has a critical point. In other words, the derivative is 0, so that means when x is 1/4, f prime is equal to 0. In other words, there is a horizontal tangent line. Okay, so the graph either looks like that, it looks like that, it looks like, well, we kind of already know. I mean, the graph is going to go up like that, so because the third degree polynomial, so this is what the first critical point will look like. It's going to be a maximum, and then the next critical point will be a minimum. Okay? So that's how you answer the question. Set it equal to 0, find where f prime is equal to 0, and then solve. Okay? Now I want you to do one, and the one I want you to do is this one here. It looks kind of scary, but it's not too bad. So pause the video, try this one, try to find the critical points. Okay? And time back in, r prime, I'll do this one in green, r prime is equal to 240 t squared plus 20 t to the third minus 10 t to the fourth. R prime is equal to 0 when? Well, when this function, now here's the deal, I'm going to also factor out a 10t to the second, okay, while I'm doing this. So I'm going to set this whole guy equal to 0, but at the same time I'm going to factor out the 10t squared. If I factor out a 10t squared from the first term, I get 24. Factoring at 10t squared from the second term, I get plus 2t, going slowly here because this is where it's easy to make a mistake, and then minus t to the second. Okay, so when this being the derivative, when r prime is equal to 0, I've got it factored here. I need to solve for t. Okay, now I notice here that I've got my trinomial here, but I don't like the fact that I've got a minus sign in front of my t squared. So I'm going to go ahead and factor out that negative sign and then rewrite the terms in decreasing order of power. And so we're going to do that right down here. We've got negative 10t squared. I'm going to multiply that by t squared minus 2t minus 24. Now it's much more pleasing to my eye to take a look at that because I know how to factor that with a t squared there. I put a t there and a t there. Okay, and then we see that we have negative 6 and positive 4. So negative 6 and positive 4 give us negative 24. 4t and negative 6t give us the negative 2t. I just had to pause the video, so I don't remember exactly what I just said. But I can see where we're at. We need to solve for t. We see that t is equal to 0. We see t is equal to 6, and t is equal to negative 4. So that's where r of t has critical points at those three values. Hopefully you got that. I'm going to stop the video here, and then we'll do another video or two, and we'll look at some other examples.